Alrighty, let's see. Okay, so now these are masses, right? So remember that we're trying to find the force on mass A. Remember that, like Mr. Murray, all masses attract each other. The force of gravity is always attractive, just like me. Okay? So the force of C on A will be directly towards C. It's attracted to C, right? So there's FC of A, right? And the force of B on A is, what is it, over 2 and up 1. So it's like, whoosh. There it is, right? Here's the force of B on A, right? Well, this force of C on A, this one's the easy one, right? That is a 45-degree angle right there. That's because it's down as far as it is over, right? This angle here is going to take a little bit of maths to figure out. So let's figure that out. I'm going to go, if I look at this triangle here, I'm up 2 but over 4, right? So that's going to be the inverse tan of opposite over adjacent, so 2/4, right? I'm just looking at this geometry, right? We're up 2 here. This is 2. This is 4 over 1, 2, 3, 4. These are meters, right? Okay. Can I draw that? Right, so the inverse tangent of 2/4 is 26.565. That's what this angle is right there. Okay. So now let's figure out the magnitude of these things, right? So let's find FBA, right? And that's going to be, this is gravity, right? So it's GMM over R squared, right? So the G is 6.67 E minus 11. Okay, let's see. The first mass is B. B is 2.1 megakilograms, right? Which, by the way, is a gigagram. Okay, so 2.1 E6. That's a 6. And then A is 1.6 E6. And then our distance from B to A is 4 and 2, right? So 4 squared plus 2 squared. Now, really, we've got to go square root of that and then square that, right? But of course, the square root and the square, outer square, just go away, right? So you can just go 4 squared over 2 squared. Okay, so let's figure that out. So let's go, I'm going alpha F1, grabbing that first fraction, 6.67 E minus 11 times 2.1 E6 times 1.6 E6 over 4 squared plus 2 squared. All right, do I have everything correctly? I think I do. That's 11.20, right? And then let's see, it's B, it's the force of B on A, right? So it's up, it's right, and up, and it's at an angle of 26.565 above the x-axis, right? All right, so now we've got the angle of it and we've got the magnitude of it. We're in good shape. Okay, so let's find FCA. This will be 6.67 E minus 11. There's our G, right? C is 6.3 megakilograms. I think that's not a thing. Gigagrams, 6.3 gigagrams. Okay, let's see. And then A is 1.6. Doesn't, by the way, matter what order I put them up there because multiplication is commutative. And then our, let's see, to C and A, that's 2 over 2 down, so it's 2 squared plus 2 squared. Okay. So I'm going to grab that thing. I'm just editing this expression too. Okay, 2 squared and 2 squared. And then I just have to change this to 6.3. Okay, do I have it all right? I have everything in the right place. Okay. 84.0 0, 4, 2. And this one is right and down at 45 degrees with the x-axis, but also with the y-axis, right? Okay. Okay. So much space we need. Boxed it off. So here's our first step, right, is that we're going to find the magnitudes and the angles, right? The next step is to set up our little vector thing, right? So we're going to go FBA, FCA, and then we'll find the sum. All right, let's draw the little lines there. It's amazing. Oh, whoops. Now I don't have any space. So this will be our x direction. This will be our y direction over here. That's such a lot of room. Okay, so let's see. F of B on A. Okay. This is to the right, so the x component will be positive, right? And so we're going to go 11.2056 cos, and then what's that angle? 26.565. All right, here we go. I'm ready to go. This guy, boom, cos 25. I'm just using up arrow on my calculator here. It's so accurate. 10.023 roughly newtons in the x direction, and that's positive because it's to the right. If you look at this force, right, we go to the right, we go up, right? So it'll have a positive x and a positive y, right? So this will be 11.2056 sine of 26.565. I'm using SOHCAHTOA, right? Okay, this angle here is the opposite side. This is the adjacent side, right? Here's the hypotenuse. That's how I know it's sine and cosine, right? Okay, so let's do this. Let's go. I actually just grab the expression I just made, and I go back through it and change the sine to a cosine. 5.011 newtons. That's positive newtons in the y direction. Okay, let's find FCA. That magnitude is this, right? So C is, let's see, 84.042. That's a 4. And then I'm going to go cos 45. Okay, so let's grab that number. Boom. Cos 45. 59.43. 42, I'll say 427. It's 59.427. Now let's look at this. Let's see. Okay, so we're doing FCA, so it's going to be to the right and down. Since it's to the right, this will be positive newtons in the x direction, right? And then the y component is going to be negative, right? Because it's down. This force is down. The force of C on A was down. So that's going to be negative. So let's go 84.042 sine of 45, which is, of course, the same number, but it's negative. So negative 59.427 newtons in the y direction. Okay. So now we are ready for the sum. Are we ready for the sum? I think we are. These are both positive, so let's just add these guys up. That guy plus this guy is 69.449 in the x direction. Let's add these guys up. This guy's positive, this guy's negative, so I'm going to go 5.011 minus the 59. And this is negative 54.415. All right, now what remains to do is to draw a picture of this thing. So it goes over, it goes up, and here's the vector. Ooh, I'm getting so good at drawing these lines. It's so hard to draw lines on this thing. Okay, so I'm going to find this angle right there is tan minus 1. This side here is, by the way, 69.449. This is, oh, poop. Oh, I drew it wrong. This is so sad. Okay. Oh, and I'm so far into this video. Okay, is there an eraser on this? Pointer options, eraser. Oh no, I could just like erase stuff. All right, let's just go with it. Okay, so I drew this up, but this really should go down. Okay, so let's change the pen color. Let's go to red. All right, so, oh, can I do white? I can't. Okay, I'm gonna stick with red here. So let's draw this thing correctly, right? So I gotta go over, right? And then I have to actually go down. That's so sad. And I drew such a nice thing, right? So ignore the blue and look at the red here. Okay, so this angle is still going to be, so this is 69.449. This is, you deserve a better video. This is minus 54.415. Okay, this is the real vector, so it goes over to the right and it goes down, right? Okay, so let's see. I was just zoning out there. Okay, so this angle right there, this theta, is going to be inverse tan of 54.415 over 69.449. Okay, so let's go with second tan of that guy, the 54 divided by the 69. Let's see if I can not mess up anything else. Might be a challenge. Okay, so this angle is 38.1 degrees. So 38.1 degrees. And then the magnitude of this is going to be, that's this thing here, right? That's going to be 69.449 squared plus 54.415 squared. So I'm going to go square root of that guy, boom, squared, plus parentheses, this guy, n parentheses squared. When you put the negative number in there, you gotta, when you burp it back up, it's got a negative, and TI calculators have a curious habit of making negative numbers squared positive. Okay, so 88.2 is what I'm getting there. Okay, so here's the picture. Notice eventually I drew it right, so to the right and down. The vector is this one. Make sure you use an arrow. Make sure you label an angle. Make sure you label the magnitude. There we go, 88.2 newtons, so we've got it. All right, sorry about the bad picture.